All right, Algebra 2, we're going to talk about piecewise functions. Piecewise functions. That's what the cool kids are doing. This is lesson 79. Stick with me.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, piecewise functions. Lesson 79. So a piecewise function is just a function comprised of at least two functions. So there's pieces of that function. So let's get right into it. Let's start with an example. All right, so this table represents admission prices for certain age groups, okay? So for under 12, it's $5. In between 12 and 50, it's $12. For over 50, it's $10. So we're gonna graph what that looks like. So when I say under 12, algebraically, what that means is just x is less than 12. It's not less than or equal to 12, it's less than 12. So in between 12 and 50 is now including 12, so we want x to be greater than or equal to 12 and less than or equal to 50. Okay, and then over 50 is basically just x over x is greater than 50. Okay? So let's graph that, see what it looks like. So how do you say x is less than 12? All right, well, 12 is about right here. And how much is it for less than 12? It's $5. Boom. Okay, so this graph represents everybody under 12. All right, you can't be 0 and you can't be less than 0. So we're going to put an open circle on each end because we don't want it to include 12. Go to anything in between 12 and 50 inclusive. So when I say inclusive, I want it to include 12 and 50. All right, 12 is right there. So how much is that? It's $12. Lots of 12ness. So we're going to put a solid dot there all the way to 50, which is right here. So this is what this graph looks like. Okay, then the last one is greater than 50, and this is $10. Okay, so greater than 50. So we want an open circle again, remember, because we don't want to include that. And we're just gonna go on forever. Okay, does that make sense? So that's what the graph looks like. Now, this kind of looks like steps, and that's what this function is called. It's called a step function. A step function is a piecewise function that is constant for each interval in its domain. So these are the different intervals. The interval between 0 and 12, the interval between 12 and 50 inclusive, and the interval greater than 50. So these are intervals, and the value is constant on that whole interval. So to evaluate a piecewise function, first you have to figure out what interval your x is in. Okay, so if you are given an x, figure out what interval that is, and then find the range value. So let's do example 2. Let's try another one. This is what a piecewise function could look like. The value is 12 when x is less than 0. The value is -5 when x is in between 0 and 5, okay? And the value is 2 when x is greater than or equal to 5, okay? So let's label our graph here. Let's say our y values are every 2, so 2, 4, 6, 8, 10, 12, probably stop there. -2, -4, -6, -8. Okay, so let's graph this. So let's do this one first. For x is less than 0, the value is 12. So open circle there, and we're going that way. So for every x that's less than 0, it's going to go up to 12. All right, let's do the next one. For every x that's in between 0 inclusive and 5, the value is -5. So I'm going to put a solid dot there, Then I'm going to 5 here, and I'm going to put an open circle because it's not including 5. All right, one more. For values greater than or equal to 5, the value is 2. Okay, so that's what that looks like. Now the example doesn't tell you to graph it, but I like to see the visual of what's happening. The directions say evaluate the piecewise function when x equals 0 and 5. Okay, so for f of 0, first we have to determine what interval 0 it belongs to. Okay, so it's not in the blue interval because it's not equal. 0 is not less than 0. 0 is equal to 0. So that would be in the green interval. So what's the value? -5. Okay, so what about the value of 5? Well, first you have to figure out what interval this is in. All right, well, it's not, 5 is not less than 5. 5 is greater than or equal to 5. So that's in the purple interval. So our value of 5 is 2. Okay, so real easy to evaluate piecewise functions, especially if they're step functions like this. You just have to figure out what interval is in, and it gives you the answer. So it's kind of like looking on a table or a chart to figure out what the answer is. Okay, so let's go the opposite way. Let's say we have a graph and we have to write the function, write the piecewise function. Okay, so let's see what the graph looks like. So I made it a little bit easier and put some color to it. So let's just see if we can write this function. Let's look at it first. Look at the blue line. All right, it looks like the x values are in between 0 inclusive and 2. Okay, look at the green line. It looks like those values are in between 2 inclusive and 4. Look at the red line. Looks like those values are in between 4 inclusive and 6. So how do we write that function? Well, f of x equals 3 different pieces of this function. So look at the blue function. It looks like the y value for the blue function is constantly 2. So the value of x is 2 when x is in between 0 inclusive and 2. Let's look at the green one. It looks like the value is 4 when x is in between 2 inclusive and 4. And it looks like the value is 6 when x is in between 4 inclusive and 6. Does that make sense? That's not too bad, right? All right, let's do another one. Okay, so let's see if we can graph this function. So I'm going to color coordinate this again and write some xy values here, okay? So let's say x is -2, right? Because we're choosing x's that are less than -1. So when x is -2, then we get 2 times -2 is -4 plus 1 is -3. All we're doing is plugging in -2 into this equation. All right, let's try -3. -3 is -6 plus 1, which is -5. All right, so if I graph those, -2, -3, left 2, down 3, left 3, down 5. These are just going to keep going following that pattern, okay? And where it's going to stop is right here at -1. So this guy looks like that, okay? We know it's a straight line. It follows a straight line because that's a linear equation. Next, let's grab this interval. So this is our green interval here. So for x's that are in between -1 inclusive and 2, our expression is -3x. So let's plug in some values. Let's plug in -1. Well, -1 times -3 is +3. All right? Let's plug in 0. 0 times -3 is 0. Let's plug in 1. So 1 times -3 is -3. All right, let's graph those. -1, 3 is right here. 0, 0 is right here. And 1, -3 is right here. So we're gonna graph that. But where do we stop with this line? We know we start here, but where do we stop? Well, it's gotta go all the way up to 2. So let's just plug in our 2 value for x and see what that gives us. Well, that gives us -6. So it's gonna go all the way to -6 here, but we don't wanna touch it. So we're gonna just do an open circle. All right, does that make sense? All right, last one. Now this is a little trickier, but we know how to do this. We know how to graph quadratics, right? That's what that is. So it looks like it's our mother function, x squared, shifted down 10. Well, let's just plot some points, just because we can. So we're going to start with 2. So 2 squared is 4, minus 10 is -6. So that's cool. That ends up being the same value as the one before, so we're going to just fill that in right there with our red. So then let's plug in 3. So 3 squared is 9 minus 10 is -1. Let's plug in 4. 4 squared is 16 minus 10 is 6. 5 squared is 25 minus 10, which is 15. I don't think we're going to go up that far. But remember, it's a parabola, so we don't want to connect these linearly. We want to connect these just point by point, then use our best guess on what that would look like. 2, -6. And remember, the vertex is going to be at 0. Like if I drew this whole parabola, the vertex would be at 0 because it's just shifting down the mother function 10 units. 2, -6. 3, -1. 4, 6. 5, 15 goes up there. So this graph looks like this. Okay, it's kind of curvy. This is what your piecewise function will look like. Okay, there's another example 5, real life application. It's postal service rates. You can look at that for a little bit more information on a really good example of a step function. But that's it for lesson 79. Well done.
Black man!